Welcome back, learners. You know, in our previous lecture, we were discussing that how we are supposed to decide the dimensions of the column as well as how we are supposed to decide the shape of the columns. I told you the significance of the moment of inertia in order to choose the rectangular column. And I already explained you that the out of the two larger and shorter dimension, usually we keep the shorter dimensions of the column equal to that of the width of the wall or the thickness of the wall. According to that, in for our project convenience, now we have taken the three column grouping. Column number one, which is of the column which is having the low load bearing thing of the dimension 9 inch by 9 inch, whereas column number 2 of the medium load bearing column which is of 9 inch by 1 feet, and column number 3 which is of very high load bearing structure column with the 9 inches by 1 feet 6 inch columns. So these are the three dimensions of the column that we have considered. In the same manner, we have some strategies in order to decide the beams dimensions also. Now, when we are deciding the beam dimensions also, we have to one thing understand in mind that the breadth and depth of the beam has to be decided, and whatever we are going to decide here, definitely it will not be a final dimension of the beam or column. It will be the preliminary dimension, and we have to analyze and we have to check it whether the dimension what we have taken is sufficient to take care of the load. Now, similar to the column, in the beam also, we are not going to have the same dimensions of the beam for all the beams. Here also we do the categories of the beam. Okay, so some beam will have one dimension which is of smaller in nature, which receives the less loading, and some beam will be of some dimension which receives the medium loading, and some beams will be of the larger dimension which receives the heavy loading. Before we move on to that, we have an IS code provisions also in order to decide the beam dimension. One thing we have to make very clear that when it comes to the beam, the two dimensions that we are supposed to take is the breadth and depth of the beam. So similar to the column here, the breadth of the beams, okay, the breadth of the beams will be always equal to the thickness or the breadth of the wall, because again what will happen if we change the breadth of the beam uh, either smaller or greater than equal to that the thickness of the wall, then what will happen, definitely it creates again eccentricity. Okay, again it creates an eccentricity. So what will happen, so certain portion of the beam will be coming outside. For example, if I want to show it in plan, let us assume that, so this is my beam. Okay, so this is my beam. Okay, so definitely this will be your slab like this, it will be there. I'm just writing the cross section. Okay, like this it will be there. Now below this definitely there will be a wall. So if my thickness of the wall or my width of the wall and my width of the beam are not uniform, then either the eccentricity will come like this eccentricity will come. Okay, you can see that. So like this eccentricity will come, so certain portion of the beam, so it may come either outside of the building or it may come inside of the building. So both will create a problem. Even in case if it comes inside, then definitely it disturbs the architectural appearance. It doesn't look good. It won't give the pleasing appearance. Okay, it doesn't looks good. So therefore, usually what we do, we keep this beam width equal to the width of the wall. Okay, definitely we won't keep the width less than the width of the wall. We keep equal to the width of the wall. Okay, so that is the best option, so that you will be having a very pleasant or a very good architectural appearance inside the building. Okay, so therefore here again in our problem what we have considered, our width of the beam will be restricted to the 9 inches because we are using 9-inch walls. Only the partition walls are 5 inches. Other than that, all are 9 inches. So therefore we restrict the width of the beam always equal to the 9-inch walls. So therefore it will be 9 inch. Only the depth of the beam is going to vary. Okay, only the depth of the beam is going to vary. Now, before we move on to how to choose or how to make the depth of the beam, the one more point I would like to make very clear that I already told you when it comes to the beam, we have mainly two categories. What are those two main categories? The first category will be of the roof beam. The second category will be of the plinth beam. Okay, the first category will be of the roof beam. The second category will be of the plinth beam. Okay, so we have to understand here that the load received by the plinth beam will be very less as compared to the load received by the roof beam. Okay, the load received by the roof beam will be very higher compared to the load received from the plinth beam. You may have the question, why? See, the plinth beam will receive the load only which is equal to the weight of the wall. Okay, so you know plinth beam is provided just to make the structure stiff and in order to have a platform to construct the wall at the ground floor. So therefore, the load received by the plinth beam will be less compared to the load received by the roof beam. So therefore, we can have the smaller dimension for the plinth beam compared to the roof beam. But we will be keeping the width of all the beams equal to 9 inch here, which is equal to the width of the wall. So we are not supposed to change the width of the wall. It will be 9 inch. Now the depth of the beam will be decided. The depth of the beam will be decided based on the L by D ratio. Okay, based on the L by D ratio which we have considered in the IS 456 2000. So for example, if I open the IS 456 2000 in the class 23.2.1, based on the deflection criteria of the beam, you can see that the vertical deflection limits may generally be assumed to be satisfied provided that span to depth ratio are not greater than the values obtained as below. The basic value of span to effective depth ratio up to 10 meter. Okay, up to 10 meter. So we can use directly for cantilever, that is L by D is equal to 7. For simply supported, L by D is equal to 20. For continuous, it is L by D is equal to 26. In case if the span is above 10 meter, the value in the A, that is this value 7, 20 and 26, has to be multiplied by 10 by span. It has to be multiplied by 10 by span in meters, except for cantilever, in which case the deflection calculation should be made. So now in our problem we have only two kinds of beams. One we are having the cantilever beam and another we are having the continuous beam. So nowhere you can expect the simply supported beam. One we are having the cantilever beam, another we are having the simply continuous beam. Okay, for example, if I take this, these beams are cantilever beams, this one and this one. Okay, and this is your simply supported beam. This is your cantilever beams. So these are your simply supported beam, except that all these beams we can take it as continuous beams only. Okay, we can take it as continuous beam. Now, based on that, so what we will do, we will make them the groupings. Okay, so and by looking into the dimension, we have to make them the groupings, right? Okay, so for that, what we will do, we will just open an Excel sheet. Okay, we will just open an Excel sheet. So now what I will do, I'll just give some numbers here. Randomly, I'll be considering each and every beam, and let us write the corresponding L by D ratio. So here I'll write the, okay, here I'll just write the beam length. I'll write the beam length. Okay, I need it in meters only, so let us write that beam length. I'm going to write it in meters. Okay, so now definitely I have to take I have to decide whether it is a cantilever beam or a simply supported beam or a continuous beam. Therefore I'll write L by D value, L by D value. Okay, so then I'll be calculating the corresponding beam depth. So that also I'll be writing in meters only. So then we will convert it into the feet. Okay, yes. So you know that 1 meter is how much? Right? You know 1 meter is equal to 3.2 feet. Okay, so 1 meter is equal to 3.2 feet. That means I can write 1 feet is equal to 0.30 meters. 1 feet is equal to 0.30 meters. Okay, yes. So now so let us take this. So we will start one by one. Okay, so we are not going to consider the plinth beam here because the load carried by the plinth beam will be less. Now, so let us take this beam and let us consider this as a continuous beam. Okay, so what is the dimension of this? So the dimension, okay, so if I check the properties, I can see that the dimension, right, it is 3 feet 6 inches. Okay, so if you have a doubt, I can check in the dimension only. It is, sorry, it is 14 feet 6 inch. Okay, the length of this beam is 14 feet 6 inches. Okay, the length of this beam is 14 feet 6 inches. Right, so I can almost take 15 feet only because we will be on the more safer side. Right, so if that is 15 feet means it will be 15 feet multiplied by 0.30, right? So 15 multiplied by 0.30. Therefore, I will develop the Excel sheet. So what I will do, so I will just write this value. Okay, so 15 feet multiplied by, okay, 15 feet multiplied by 0.30. Okay, or just what I will do, I will just add one more column. Okay, so this let it be in feet and this let it be in meter. Okay, this let it be in meters. Okay, so this let me give the value as 15, right? So now for this I need, it has to be 15 multiplied by 0.30 will give you the beam length in meters, right? So I know I'm taking this as cantilever, it is a continuous beam, so for that L by D ratio, so the beam length is 4.5, which is less than 10 meters, so therefore I can directly take 26, right? So therefore what will be by D beam depth? So L by D, that is this will be 4.5 multiplied by 1000 to convert it into the mm divided by this value will give you, sorry, one second, I just made a small mistake, is equal to 4.5 divided by 26 multiplied by 1000. Okay, so that will give you the value in mm, that is 173. Okay, so that is 173 mm. Okay, so 173 mm is the depth of the beam, right? Okay, yes, so therefore I have done this beam, so I will make it into red, right? So then what is the dimension of this one? So the dimension I can take from here to here. Okay, so dimension if I take, it is coming around 11 feet 9 inches. I can make it as, so 12 feet. So this beam as well as this beam both will be of the 12 feet only. So therefore what I will do, I'll just make 12 here. Okay, so then definitely what will happen to this? So I can just bring this like this, right? So it will be 12 multiplied by 0.3 will give you 3.6, right? So then, so for this again 26 only, no change, right? So then it will be 138 mm. Okay, 3.6 meter, 138 mm, right? Yes. (138 mm). Okay, that is depth. Then let us take this one. So what is the dimension? The dimension will be from here to here. So what is this? 8 feet 1 inches. Okay, 8 feet 1 inches. So 8 feet 1 inches means I can make it as 9 feet or 10 feet only. So I can make this as well as this. Both I can make it as 10 feet. Okay, so when I make it 10 feet, then it will be 3. This also I am taking 26. So I am getting 115 mm. Okay, I am getting 115 mm. Yes, so this is done. Now cantilever projections we will take at the end. Now I need to take this beam length. So what is this? Here to here you are getting how much? 13 feet, means I can almost make it as 15 feet only, on to more to be on safer side. So 15, so 4.5, so 26 again, sorry, 26 here, again you are getting 173. Okay, so this beam. Then what about this? So this I'm going to take this as again continuous only. Okay, so continuous beam, 8 feet 9 inch, I can make it as 10 feet itself. Okay, this and this almost I can make it as 10 feet, but this let us take it as simply supported. So this let us take it as continuous. So therefore this I will make it as a red color. Okay, this I will make it as red color. So this let us keep it as yellow color, because in order to identify that differently I am keeping this as yellow color. This I will make it as red color. Okay, almost it is coming 10 feet, right? So 10 feet I already have. So 10 feet, so 326. Okay, that is 115, whereas another will be again 10 only, but there my value of L by D will be 20, because it is a simply supported. There it becomes 150 mm depth. Okay, this will be 150 mm. Then again I have this, right? So I have this, and I have this all these three. Okay, so you can see here we cannot able to completely separate this and this. So usually when the casting is done, all these three beams will be considered. Therefore what I'll do is I'll just calculate this from here to here, that is 9 feet 8 inches, that is 10 feet. Same thing I'll be taking for all the three, that is this one and this one. So this everything I will take it as 10 feet itself. Okay, so 10 feet, right? So I'll make it as 10, but again it is a continuous beam of 26. I'm getting 115. Okay, getting 115, right? Even this can also be, I can do, I have already done, right? So then this and this will come. Okay, this and this will come. So this, what is the dimension? This I have to take it as continuous only, that is 12 feet 2 inches. I will make it as 13 feet, but this again I won't consider it as a continuous beam. Okay, so let us take it as simply supported only, that is 13 feet beam. So one 13 feet, another 13 feet. Okay, that is, this will be of the continuous one, whereas this will be of the simply supported one. This will be continuous. Okay, this will be continuous, this will be simply supported. So therefore, so here it will be continuous means 26, whereas simply supported means 20. Okay, yes. So then similarly here the same dimension I can take, so therefore I can make it as a red. Okay, so this all, they are all just the partitions walls, so no need to consider them much. So therefore let us keep it in green color only. So this dimension I have to take from here to here. What is the dimension? It is 14 feet 6 inches, that is almost 15 feet. This also I will take it as almost 15 feet only to be on safer side. So therefore I have to change these two to red. So 15 feet. 15 feet already we have, right? 4.5, 26, that is 173 you are getting. Okay, 173. Yes, so now this comes the major one. So this is the longest beam that we have. Let us see what is the dimension from here to here. It is 20 feet 11 inches. I will make it as 21 feet itself. Okay, I will make it as 21 feet. Okay, I will make it as 21 feet. Right? Yes, definitely it will be a continuous beam of 21 feet. Okay, so the 21 feet, 6.3, it is not coming more than 10 meter, no issues. So 26, you are getting 242. Okay, you are getting 242, and this same I can do here also. Okay, that is of 15 feet. So therefore no need to calculate again for this. So this and this. Okay, so this will be of the 15 feet. So we have a small cantilever that we will come at the that time, right? Then again I can see this one and this one, this and this I can make it as the continuous beam, whereas this will be simply supported beam. So therefore what I have to do, I have to just check the dimension from here to here. We are getting 9 feet 7 inches, that is 10 feet. Therefore this and this will be continuous, whereas this will be simply supported, right? So I have to take 10 feet again. So I can see 10 feet. So 26, I'm getting 115. Okay, yes. So then this beam and this entire beam is there. So you can just take dimension linear. So how much it is coming from here to here? 1 second. Here to here, 10 feet 2 inches, almost it is 10 feet only. We have already have the depth of the 10 feet beam, so therefore I can change it. Okay, whereas this one I need to check, it is dimension linear from here to here. 7 feet 9 inches, that is almost 18 feet. Okay, it is an 18 feet beam. Okay, so I need to change, so 18. Okay, so 26, so it is 207, it is coming. Okay, yes. So then after that, this and this I can take it. So what is my dimension? Here to here, it is 10 feet 6 inches, almost 11 feet. Okay, this one and this one will be of the 11 feet. This and this will be of the 11 feet. I think we already have 11 feet, or else no issues. 11, so 3.3, 26, you are getting 126. Okay, 11 feet, right? So then I have one beam here, so that is from here to here. It is coming 13 feet 6 inches. I can make it almost 14 feet, right? So that is 15 feet only, it is there. I can take 15 feet dimension only, so no, it will be on more safer side. Okay, yes. Then I have this beam, right? So what is this? The same length, so therefore no issues. Then I have this and this beam, almost the dimensions are same. Okay, this and this, so we will just check the dimensions. 9 feet 6 inches, 11 feet. So both, out of that the highest is 11, 11 we already have, right? Okay, yes. So these two also I can make it as red. So therefore all the red color shows the continuous beam, all the yellow color shows the simply supported beam. Now we have left with only the cantilever beams. So for that, so what we have to do, so now this is cantilever. What is my dimension? 6 feet 1 inch. Okay, 6 feet 1 inch. Okay, 6 feet 1 inch. So how much I am getting? So this is 6 feet 1 inch. Almost I can make it as 7 feet itself. So 7 feet, so 2.1 meter, it is 7. You are getting 300 mm depth. Okay, you are getting depth as 300 mm, right? Yes. So this no issues, we will make it as a simply supported beam only, right? So this is a cantilever. So then one more cantilever we have is here. This is a very small cantilever, no issues, 3 feet 1 inch. Okay, I can make it as 4 feet only, on more on safer side. 7, you are getting 171. Okay, so therefore this green color we will keep it in the cantilever portions. Okay, yes, this green and partition wall. Here I have to check, so what is the dimension from here to here? 3 feet 5 inches, that is 4 feet already I have here. 4 feet cantilever I have. What about this one? 6 feet 6 inches, that is 7 feet, that also I have, so no issues, right? So like this, now what I have done, I have written, I have made the groupings. Now in that, one thing is clear, that all the beams whatever I have, okay, all the beams whatever I have make the width equal to 9 inches width. I am not changing any width dimensions, it is always 9 inches only. Okay, so we are not changing the 9 inches, right? So therefore now if you want to see this, if I want to see this 173, right, 173, right? So almost I can make them one more 173, I can almost make them one category. Okay, so One more thing I would like to make you very clear that students, whenever we are drawing the cantilever, okay, we have to make sure that out of this beam and this beam, which is having the larger depth. Okay, so this beam and this beam when I check, so because usually when the cantilever beams are casted, so that beam will be casted along with this beam. So usually we cannot maintain the different depths of the beam. We cannot maintain the different depths of the beam. Okay, we cannot maintain that. So therefore usually what we will do is we will maintain the same depth out of whichever is greater. Now according to these two, this will give you the more dimension. Therefore I am maintaining this depth to this only. Okay, so therefore according to that, what I can make, this 242 is the one with the highest one, so that I will make it as the different color. Okay, then this 126, 138, 115, 115. Okay, this 115, this 115. Okay, so that we can categorize one color. Even this 171, it is a cantilever, these two. Okay, so therefore you can see that one we have 300, one we have 171. Okay, so I can make this also as an yellow color. Okay, whereas this 300 and this 150, 150, I can make almost bring it to yellow color only. Okay, this 195 and this 207. Okay, this 300, this 195 I can bring it to 173 only, no issues. Okay, then 207 is one separate one. Okay, and this 300 is one separate one. So by looking into this, what I will do is I will make the three sets of beams. Only in the roof beam I am telling, I have not come to plinth beam. Okay, so what I will do, I will make the first beam. Okay, so beam 1 I will make as, the first beam I will make it as beam of depth 300 mm. Okay, let us make a beam of depth the 300 mm, right? So therefore what I will do, 300 mm depth. Okay, just give me 1 minute. Yeah, so I will make a beam of depth 300 mm. Okay, yes, yes, I'll make the first beam of depth 300 mm, that is 9 inches is the width, multiplied by, if I make 300 to inches, it is coming 11.8 inches. So let us make as 11 inch. Okay, or we can make it as 12 inch. 12 inch means 1 feet. Okay, so 1 feet beam. So let us make this as 1 feet beam. That is my first beam. Okay, if you want it in the bracket, I can write it. That is uh, that is 300 by 300, it is almost. Okay, that is my beam 1. Next is my beam 2. So that again I will make it as 9 inch will not be there, multiplied by, I will make it as 450 mm. Okay, I will make it as 450 mm. Okay, I will make it as 450 mm. So when I make 450, it is coming around 17.71. Okay, that means in that 17.71, right? So 17.71 inches it is coming. It means if I remove 12, or let us take it as 18 inches, that 18 inches if I remove, that is uh, 12. Okay, if I remove 18 minus 12, 6 inches. It means it is 1 feet 6 inches beam. Okay, it is 1 feet, okay, 1 feet 6 inches beam. Okay, it is 1 feet 6 inches beam. That is, I can write 300 into 450, right? Then I will make one more beam, okay, beam 3 of the dimension 9 inch by, so that means I am taking now the dimension of 500, okay, taking 500, that is 19.6, that is almost 20 inches. Okay, 20 inches means, so 12 inches if I remove, I am going to get 8 inches, that is 1 feet 8 inches beam. Okay, that is 1 feet 8 inches beam. Okay, that is 300 into 500 mm. So like this, let us make the 3 categories of the beam. Once these 3 categories of the beam is done, now after that, now what we are supposed to do, we have to start modeling. Before we have to modeling, so what is our work? Our work is we have to first define them. Okay, so in the next video, in the ETABS software, so already the materials has been defined. So let us define the sections of the beam and column, and let us start modeling it. Okay, I hope you understood. Thank you, learners.